Welcome to our training segment at Solar Pulse. So today we want to talk about solar system sizing, how to make sure you size your system correctly. We were invited recently to one of our clients, as colleagues who had their system installed, but it was giving them problems. So they invited us. We went through the troubleshooting and everything else was done correctly except for one ingredient, which is called solar system sizing, which is the first port of call whenever we are designing a solar system. Obviously, we may have different designs that we have come up with to make sure it is to sell to our clients, but it's important to make sure the system that you install for your client is tailor-made to meet their needs, or at least they are aware of the shortcomings of their solar system. Hence why we are here to talk about solar system design. So this client we are talking about, the way the system was designed, they had 4,000 watt solar panels, a 200 Ah lithium battery, and a 5 kVA inverter. Now, when you look at their load now, they were operating in the daytime, they were operating around 4,000 watts. In the evening time, their load would drop to most probably around 2,000, 2,500, which was still fairly high based on the system that was installed. And the reason why they were facing these challenges was because their pumps were not energy efficient. They had a bigger booster pump, which they used to pump water, and they also had another 1.5 horsepower pump, which was the submersible, which was feeding water into the tank. And the way the system was designed is they would switch on all the pumps simultaneously if they want to boost water into the house and if they want to fill up the tank. So we had to reverse engineer and make sure that they operate their system a single pump at a time. During the day, they just operate their submersible pump, and the booster pump can only be switched on in the evening, where they and reduced it to 0.75, which doesn't consume a lot of power. So it's important to design a system for a client, do all the load audit, understand the requirements of your clients. If there are any changes that must be done before you supply the solution, that needs to be looked at. Otherwise, the system may be considered substandard or failure to meet the needs of the customer. So, just to look at various aspects whenever you are designing a solar system. So, there are factors that you need to put into consideration whenever you are designing a solar system, and that includes the autonomy of the system. So you've got what is called autonomy of the system, and autonomy, we're talking about how long do you want the system to operate for during the day as well as in the evening, especially when there's cloud cover. So that would determine the amount of solar panels that you install and the capacity, the battery capacity that will be installed on site. We also look at what is called, you also need to identify whether the system is on grid or off grid. If the system is on grid, it is an integration of the power supply, so that whenever the power supply is available, it's also powering the loads. And when the power supply is not available, the solar is also supplying. So it will be an integration of the grid, maybe a generator and solar working together. Or is it an off-grid system? Off-grid, basically, it's literally running off-grid. You want everything to be dependent on the solar system, which means the system has to be big enough to accommodate the operations. You also need to look at the weather patterns. Obviously, in the southern hemisphere, we have a lot of sun throughout the year, but in the northern, they have cold days, they have snow and all sorts of things. So that also determines how you size your system. And last but not least, you have to understand the requirements of your clients. Are they looking for a backup system, or they are looking for a full-time operational system? If it's a backup that they require, then you are supposed to be in a position to design it based on that and still explain to the client the limitations of your offering. There are a number of things that you have to look at as you are designing that solar system. And number one, as we said, we talk of the load audit. This is a very important aspect where you ask the customer their expectations as they are putting up their new investment. Do they want to operate the entire house? Do they want to operate some of the components or appliances in the house? What is it exactly is your client expecting? Once you know what the client is expecting, then zero down to get the power rating of all the equipment that they want to power up. For example, in this scenario that I was talking about, obviously they would have said, we have a booster pump and we have a submersible pump. So in your thinking, you're thinking most probably maybe it's a 1 horsepower, it's a no-brainer pump that can operate on my offering. Only to discover that the pumps were too big, they needed to be toned down to make sure they operate efficiently on this particular setup. So get all the finer details, the power rating of every equipment. If they are going to run a submersible and a bore pump, what are the sizes? If they are going to run fridges, how big are those fridges? Is it a double door fridge, or is it those upright which are energy efficient? What is it they are running? That way, when you get all the full detail of that information, you're able then to design for them. You're able to calculate how much power they will be able to use afterwards. So once you have gone through the equipment and the power rating, you also need to discover what is the running time of this particular equipment. It's important to know, okay, do they run everything 24/7? Or do they run certain equipment during the day? Then you know how to size up your system. If they run, for example, they run their pumps during the day, what it means is that you can put up more solar array during the day to compensate for that usage. Then in the evening, they can reduce their load to most probably the minimal, which could be the fridge, the TV, and the lights, which then will be able to last them most probably a couple of hours or throughout the night. So all that information becomes important to know. Once you get that information, then you calculate what we are going to call the total daily consumption. Total daily consumption. Right. So the total daily consumption is the amount of power they are going to use on a daily basis. It has to be estimated. Once you have your estimation, you are able then to cushion the sizing of your system to make sure it's maybe with about 20 to 30% incremental to make sure that system performs at optimal. If they push up the load a little bit or lowers it, the system will be able to withstand whatever condition it will be put to test on. So these things that we're talking about are very important to make sure you design that particular system. And once you know the daily consumption, you would want to go further to discover on the daily consumption, what is the daytime operational of the equipment. So which equipment are they going to operate during the day and which equipment are going to operate in the night. Because as you know, as you are designing a solar system, it's going to, obviously it can be expensive based on which side you are leaning on. If you are having more batteries, it means more solar panels. That system tends to be a bit on the high side, but as long as the budget is available for the customer, then kudos. But if not, then you also need to be lean on your battery bank. Once you are lean on your battery bank, it also means the amount of appliances that they are going to operate on that battery has to be limited to make sure the system performs well. So those are critical things that you need, information you need to research, to ensure you deliver the best quality equipment. So for a battery, obviously it is what is called the depth of discharge, which we call DOD. So DOD is how much power can you use, for example, every night of usage. Some batteries you can set them at 80% DOD or even 90% DOD. We are talking of lithium batteries. But if you are going to be installing gel batteries, the DOD could be 50%, which means the battery bank required there could be much bigger as compared to what you need on your lithium. So just to further clarify how this whole process works, so we're going to then look at a standard household, which uses maybe a TV and a decoder, right? Then we want to know the power rating. So this is the description. This is the power rating, and we also add the running time. So that's our running time there, and we want to also measure the total kilowatt hours per day, right? So what you do is that if you have a TV and a decoder, which most probably is going to consume 120 watts, what it means is that you want to operate it maybe, let's say, for 14 hours. So you've got 14 hours. This is inclusive of the day and night time. Then if you had to calculate 120 watts by 14, it will give us the kilowatt hours per day that is going to be used for this particular equipment. So in this case, it's 1.68 kilowatt hours. So we've converted to kilowatt hours, or you can just say 1,680 watt hours, whichever way. Then you also move to your fridge. So your fridge now, maybe it's an upright fridge. So the upright fridge could be taking about 100 watts. And it's important that this equipment are energy efficient, and you are also running it for 14 hours, which means it's 1.4 kilowatt hours for running, and this is daytime and nighttime. In this case, you are running maybe 8 hours during the day when the sun is fully shining. Then at night, you are going for about 6 or 7 hours thereabout. Then maybe the client also have a deep freeze there. Then he's taking maybe 150 watts. And we are talking around more or less the same time of operation, which means you are talking of most probably 2,100 kilowatts. So you are basically multiplying the hours by times the watts to give you the kilowatt hour rate. Then from there we look at the pump. Maybe they have a 1 horsepower pump, 1 HP pump. Again, the wattage for a pump is 1 horsepower is 750. And most probably they are running it during the day for about 6 hours. 6 hours basically to feed into their tank, and then allow the tank to send water with gravity to wherever it needs to go. So for their 6 hours of running, they need about 4.5 kilowatt. So then from there, most probably you've got your lights at night. With basically lights, you are running them in the night. During the day, they are switched off because it's daytime anyway. So we are talking maybe we've got 100 watts total wattage of lights. Then they are running for 12 hours in the evening, and which means that's 1.2 kilowatt hours. So this is the entire load which your client could be running, and it's good to be able to clearly calculate for your client so that they understand the values and make an informed decision as they make an investment. So in this case, if you have to add all these figures, they are also now going to help us to design our inverter. So in this case, the total is 1,220 watts in total, which is 1.22 kilowatt. Then from there, we want to calculate the daily usage consumption, which is the total of 10.88 kilowatt hours. So now you have an understanding of the total wattage you are going to run every single day, and their total consumption on a daily basis if you are going to run this equipment at this varied time that is presented here. So what you then do next is to identify which load are you going to run during the day. So basically, your TV, obviously kids may want to watch TV, your fridges are operational, your deep freezer, your pump is operational. So these loads here, these ones here, will be operating during the day. So as they're operating during the day, what it means, we have a total consumption added on, subtracting these 100 of 1,120 watts, which is 1.12 kilowatts. That's the load for the day. Then the load for the night is the remainder after we've removed the pump, which is basically this component here. So once you remove the pump, I think you are So daytime load, let's just write it here. Day load, that's 1120 watts. Then night load, that's 470 watts. Okay, so basically what it means is that what you want now is to size a system that is able to power this load for the next 8 hours during the daytime. And basically you are doing this with your solar panels. And you want to make sure the battery sizing is able to cover the 470 watts, which is actually presented right here. Now, so to do that, and now in this case, once you have all this information, now you are able to make an offering to your customer and most probably recommend to say, okay, to power all the load that you want, based on the load that you already have, this is what you're looking at. If you want to make adjustments, you can actually make adjustments from here so that you can provide a client an efficient working system. So in this case, our night load, which is 470, we can then say, okay, fine, a client may want to switch on TV whenever they want. They may want their fridge to run overnight. So we can then, just to cushion for those times, obviously they've given a specific running time they expect, we can therefore calculate to say, okay, fine, if we are to run the 470 watts of load at night, how much kilowatt hour is it going to give us? Multiply by 12 hours at night, that's about 5.64 kilowatt hours. But the actual load, if you are basing it here, is going to be around 3.42 kilowatt, which means you can slightly oversize the battery bank to make sure they don't run out, especially in case of cloud cover. Whenever it's cloudy, obviously you have little sun during the day, it means then it squares off there. So once you know the load, once you know the power rating, and you have all this information, we size the system from two fronts. So we are sizing the system from the capacity and from autonomy. So if you want to know the size of the inverter that we need, that is going to power this load here, it means we are talking of anything in the range of 1,500 and above. But at the same time, what will then determine whether you are going to supply a 1.5 kilowatt inverter is based also on the autonomy. How much time do they want from their solar system? Is their system a backup system whenever there is power cuts, or their system is a full-time system that they want to operate 24/7? So that then will determine the capacity that you are going to build and offer the customer. So in this case, like I said, the inverter could be 1,500. So in this scenario, the battery bank, because our load here for the evening, when we calculated, I think it was coming to about 5.64 kilowatt hours, right? Based on 12 hours. Based on 12 hours, right? So what it means is that the battery that we need for this particular system is anything around 150 Ah. We're talking of lithium in this case. 100 Ah could be smaller, because 100 Ah is going to produce for you, I think, around 4.8 kilowatt, which means you fall short. But because you want to give access to the client, 150 or a 200 Ah lithium battery will work in their favor in this case. So once you know okay, fine, during the day we want to run this power, you want to run 1,200, but that's not all. You also want to be running, to make sure your battery is being charged during the same time you are powering this load, so that there's no power, you are not switching on off any equipment in this case. So we then have to calculate our 150 Ah battery. We have to convert it to kilowatts, to kilowatt hours, to then find out how many watts you need, maybe over 8 hours, in order to recharge this battery. So in this case, it's going to come to 720 kilowatt hours, because you calculate that by 48 48 by 150 is going to come this to kilowatt hours. Once you have the kilowatt hours, you divide this by 8 hours of day sunshine. I'm sure it's going to give you somewhere around 900 watts. So we just round this off to 1,000 watts, right? So which means every hour you need 1,000 watts for 8 hours in order to recharge that particular battery right there. So this is on a good sunlight day, and yeah, your battery will be fully charged 100%. We are saying we need 1,000 to charge up that 720 lithium. So we add it on to our existing load, which is 1,220. So in total, we need about 2.2 kilowatt of capacity. Then maybe if we caution it around between 10 to 30%, then we can have maybe 3 kilowatts of solar array that you need. So basically what it means, with these new hybrid inverters, you can then in this case offer your client, obviously the system can be oversized on the capacity side, which is still fine. It allows them to add more load to it. So in this case, we'll offer the client a 5 kVA inverter. Then we'll offer them, number 2, maybe a 3 kilowatt peak solar array. Most probably we are talking of 550 by 6. Then the battery bank is a 150. So because it's a hybrid inverter, it comes with an inbuilt MPPT which can accommodate maybe 450 high voltage solar array where you just connect them in series, or it can be a low voltage with high amperage, which is your current, about maybe 60 amps or so, which is able to accommodate the setup. So in this case, this is what you then need to look at as you are designing a system for your client. And if you really give yourself to the process of system sizing, you can never go wrong sizing a system for your client. And clients enjoy being advised to make sure they make the right investment into their solar system. So that's from us at Solar Pulse. Please do like, subscribe, and share.